Hey students, this is Mr. Sharp again here for the fifth video for Unit 4 in our designs section for our class in Technology, Engineering, and Design. Today we're going to be going from identifying criteria constraints and talking about modeling and how we prototype and moving how we collect data through math. And everybody's eyes wink up because they hear the word math and they freak out. Well, as you've probably realized in this course, we're not really in the much of practicing numeric equations and just going through them repeatedly as so much as we are trying to use basic formulas to capture as much data that we can in order to ensure that our design will function as properly. So today we're going to be discussing how we communicate those results in that 12th step of the engineering design process through numbers, not necessarily through our own mouth of what we as the designer, as the engineer, saw from our design and building that prototype. There's different equations that you can do in order to collect data, and we'd see this in this unit, whether it be through collecting the different data tests that you've ran and run the mean and the median to see what was the average score or the average percentage of success or failure that we received. Sometimes it's through standard deviation, but really I want us to focus on two important terms that you're going to hear over if you work in engineering or if you work in technological design. And that's going to be upper specification limit and a lower specification limit. So, as we always know, collecting data sometimes involves a lot of numeric equations. Luckily, in this day and age, we use computers to do that work for us, especially when we're doing an assignment on either Google Sheets or Microsoft Excel to give us automatically the sum or the average or the median of a certain amount of data that we're collecting. So if we're trying to give our employer or our enterprise a number that they want to see be successful, sometimes we have to give them the best possible outcome that reaches far beyond, is at the highest point of success, and that's what's called the upper specification limit. This is another word for the highest number of success rate that we can receive within our numerous tests of a prototype or a design that we've completed. And then the next part, a lower specification limit. This is the lowest number that we can achieve during our trials, during our tests, that can still demonstrate the successful function of our design or our prototype. So those are the two important terms that we need to remember, even as we get caught up in how statistically we can collect data. But as we said before, we're not so much worried about how you guys can practice that and get it right on the test as much as you want to make sure what those two words are: upper and lower specification limits. Being able to use that in order to determine if your product will be successful if it were to be manufactured in mass on a wide scale. So in the next video, we're going to end Unit 4 and talking about how we propose our design, and this is usually through the proposal and for the final pitch of communicating those results. And I'll see you next time. And after this, we'll be moving into Unit 5, the design world. We're talking about a lot of different topics, whether it be in energy production, manufacturing, construction, communication technology, and we'll hope to see you there. Have a good day.